Hello friends, in my this video I am going to discuss about this very important topic which is basically called thermocouples. Okay, if you have taken sensors and measurement course or sensor and instrumentation course, then this is very important question from the exam point of view. And apart from this, if you are taking electronics and communication engineering, you should know this, the working you should know, so that then only you can apply it properly. Okay, so see, basically what is thermocouple? Just now, for the time being, forget the name and try to understand what is the funda of physics inside this thermocouple effect. Okay, so see, basically nothing much is there. Just listen to my words. See here, this is one rod. Okay, and obviously in this rod there are two terminals. Give one terminal end name as A, another is B. Now we are providing heat in one terminal of the wire or one end of the wire. Then what will happen? Eventually potential difference will produce in the two ends. Okay, why this is happening? Now this is the question. See, I am explaining it. So suppose this is one wire. Okay, cylindrical wire I am taking, obviously. So this is A terminal and this is B terminal. In the A terminal we are providing heats. Okay, now as we are giving heat in the A terminal, what will happen? This is metallic rod we are considering. You know, in metals there are metal ions and electrons. Total metal ion which are obviously positively charged, because you know from the basic concept of chemistry that metal atoms always try to remove one electron from its outer shell to get the electronic configuration of its nearest noble gas, right? You know this. So metals always try to give electrons. So basically if you consider any metal, there are large amount of free electrons. Okay, because all the metal atoms want to get the nearest stable electronic configuration of noble gas. Okay, so basically any metal has large amount of free electrons, due to which metals are basically conducting. You know this basic physics, right? So basically we can say in metals there are metal ions which are basically positively charged. Why? Because after removing one electron from the metal atom, it will obviously become positively charged, right? Because total atom is neutral. When you are removing one electron, it will become, the ion will become positively charged ion. So basically in metal there are positive metal ions and free electrons. Okay, now the total amount of positive charge which is basically generated by adding up all the positive charge of the metal ions, that is equal to total amount of negative charge which is produced by the free electrons which are present in the metal. So that if you consider one metallic rod, at any point the total electrical charge is neutral, that means zero. Total electrical charge is zero. So this is what for general scenario. But now when suppose at the A terminal you are providing heat, so as a result what will happen, try to understand it very clearly, because this is the basic concept. See, I am drawing here one metal atom, I am drawing here metal ion which is obviously positively charged, and another electron I will draw here. Okay, so see, there are electrons too. Okay, now see what will happen. You are providing heat in the A terminal. Okay, you are providing heat here. So this heat energy will be converted into kinetic energy, right or not? Obviously heat energy will be converted into kinetic energy, and that kinetic energy will increase the velocity of the particles at the A terminal. Now as the electron is very small in size compared to the metal ion, and obviously it is very much light in weight, right? Electron and one ion if you are considering, then the weight of the metal ion is far more than the weight of a single electron. Yes or no? Right. So now as a result, although same heat energy is converted into kinetic energy for both this case, but due to very low weight, what will happen? The electrons will means the speed of the electrons will be much more compared to the speed of the metal ions, because metal ions have huge weight, so that they, although they are getting kinetic energy, but they cannot move much. But electrons, they are very light in weight, right? So basically they are very light, so they will get very high kinetic energy and they can move. Okay, so what will happen? See, as in the B end we are not providing any heat, so basically we can say B is comparatively cooler region compared to the A end, right? You know, every system try to acquire the minimum energy state. Now, as the electrons are getting high energy in this heated A end, they will try to lose their energy and come to lower energy state. So what they will do, they will try to flow in the cooler region. Okay, so the electrons will basically flow from the A end to the B end. Okay, but whereas the metal ions unable to move properly because they are comparatively heavier than electrons, right? So basically now, although initially total system was electrically neutral, A and B terminal was neutral condition, were maintaining in the neutral condition, but now B end will get negatively charged and A end will become positively charged, because metal atoms, sorry, metal ions which are present in the A end are unable to move properly due to their heavy weight, but electrons are like, they are very they are getting speed, very much high speed due to heat and applied heat, and their mass is also very less, so they will move faster. Now in this case the situation becomes look like this. See, this is same rod I am considering, but if you observe now, there is some changes. See, if you consider B and A end, now see, in the A end there is majority of metal ions. Okay, so here in the A ends, because due to their heavy weight, all the metal ions are getting little bit kinetic energy, but they are unable to move as fast as like electrons. So basically compared to B end, A end will become positively charged. And in the same scenario, B end, what will happen? There will be accumulation of electrons which will come from A end, and after coming in the B end, because B end is of comparatively cooler region, they will try to lose their energy and they will come to the lower energy state. So now see, there is a charge difference, like means here in the B end now becomes negatively charged overall if you consider, and the A end is now become what? Correct, positively charged. Okay, this positive charge is generated due to the metal ions. This negative charge is generated due to electrons which are basically coming from A to B, because at the A end they are getting very high energy. So what will happen? Now observe carefully. As a result, as there is, you know always that electric field always from positive to negative direction, so obviously one electric field will be created from A end to B end, right? Okay, now see, one very interesting thing will happen. You know that force acting on an electron, if you place that electron in electric field E, that is F is equal to minus of Q into E. If you want to give the vector notation format, then F vector is equal to minus of Q E vector. That means if you place one electron, the force will, if you place one electron in an electric field, the force will, the applied force will be the opposite direction of the electric field. Now see what will happening, as the electrons are flowing from A to B to decrease their energy because they want to go to lower energy state. So now see, eventually the electric field is increasing because the charge density difference, the difference between charge density in the A and B will increase. A will become more positive and positive, B will become more negative and negative. So as a result, electric field will increase. As a result, the force acting on the electrons, suppose this is one electron which is basically highly energetic or hot electron, we also say the highly energetic electrons in terms of electronics, we also call these high energetic electrons as hot electrons. So this hot electron, suppose it is flowing from A end to B end. Okay, now see what is happening. As the electric field is very high, so force and electric field is from A to B, so obviously force will act from B to A, right? Just now I told you force acts in the reverse direction of the applied electric field. So now this force, after a certain time, the electron will reach in an equilibrium condition. Due to decreased energy, the velocity and the electron's velocity is increasing so much high that they are moving from A to B, but the force which is acting from B to A will not allow it to move further from A to B. After a certain time, between these two incidents, equilibrium will arise, and in that situation, at a particular if you are providing a particular amount of heat, then in that condition no electron flow will be there from A to B, because the heat energy which is basically converted into kinetic energy and which is basically trying to drag the electron from A to B will be completely nullified by the applied force due to generation of the electric field, the force which is basically acting from B to A on the electron, right? So these two conditions will reach in equilibrium, and at this condition obviously there is no electron flow, although but the condition is you are providing constant heat. If you increase the heat, then again equilibrium will break, and then again electron flow will be there, right? So basically see now, in between what you understood from this whole story, that if you are providing uh, heat in one end of the metallic rod, then obviously there will be potential difference created in between A and B. Yes or no? See, obviously yes. In the A, it is positive potential. In the B, negative potential will generate. And if you consider the equilibrium, you will get a particular value of the potential at B. If you suppose unable to measure the potential at A, but at least you can measure the potential at B, right? Because B is at normal temperature. In the A end, we are providing heat. Okay, so basically, due to application of heat, potential is generated across two ends of the wire, and this concept we are applying in thermocouple. See how? Very simple. What we do, we just connect two dissimilar metals in series, and in this one end of the wire, these connections, we provide heat. This is the in this junction where two dissimilar metals are connected in series, we are providing heat. So as a result, potential will be created. Suppose you just consider, if you have any confusion, you just consider only one metal. See, if you consider one metal, this is just the previous scenario what I have discussed. In the one end you are providing heat, in the other end you are keeping at normal temperature, so obviously potential difference will create. And if you consider this second metal also, again potential difference will create. But this potential difference, see, understand it clearly, that is the generated potential depends on the how mobile the electrons are in that particular metal. Suppose electrons, the resistance offered by the particular metallic element is very high, although metal provides less resistance, but suppose the resistance offered is high compared to other metal, then the electrons cannot move much, right? So basically the movement of electrons is dependent on the physical property of the metal. So basically what will happen, that how much voltage is generated, that depends on metal. So basically in a series connection, if you provide same heat in two different metals or dissimilar metals, different amount of voltage is going to create at these two terminals. Okay, this is very important because their physical property is different. So basically, upon connecting two different wires in series but heated at the junction, you are getting net voltage at the other end, because see, A has different potential, B has different potential, because those are not those are not in same potential because their property of the physical property of metal is different, right? So basically voltage across these two terminal is different, and that will create obviously one voltage difference. Okay,